In this video, we're going to be talking about natural-based functions. So natural-based function is the function of the form y equals a times e raised to the rx power. And we have two different types of these natural-based functions. First, we see when a is greater than 0 and r is greater than 0, or in other words, when both of those are positive, the function is an exponential growth. And then when a is positive and r is negative, the function is an exponential decay. So here we have growth. The first one I see as we go along the x-axis that this function gets bigger and bigger. And then for this other one, I have decay, and I see as we go along the x-axis, the function gets closer and closer to 0. And so we see here again that we have our asymptote is the x-axis. We see for both these functions that the function gets closer and closer to the x-axis, but it's never going to quite touch it. So let's look at some graphing examples. So for each of these, we're going to tell whether each function represents exponential growth or exponential decay, and then we're going to graph it. So number one, I have y is equal to 3e to the x. So I'm looking to see whether my a and r are positive or negative. Well, my a I see is 3, which is positive. And then my r is that number in front of x. Here there is a number in front of x, so it's really an invisible 1 that's there. So r is equal to 1, which is also positive. So since both these are positive, that means that this is going to be exponential growth. Now we're going to go ahead and graph this function. So I'm going to use the numbers -2, -1, 0, 1. And what I'm doing is I'm plugging in those x values into my function here. So this is going to be 3e to -2, 3e to -1, 3e to the 0, and 3e to the 1. So you could go ahead and plug each of those individually into your calculator, or you could go ahead and use Desmos. And so if I go to Desmos, I can go ahead and click this plus button and press on table. And then where it says y1, I can delete that and instead write my function, which is 3e, and I'm going to raise that to the x power. And then I need to do an underscore here. So I'm going to go back here, hit that AB button, and then press 1. And I'm going to type in my numbers here. So I have -2, -1, and 1. And so I see here I have pretty long decimals, so I'm just going to go ahead and round those to the nearest hundredth. And so when I do that, I get this is approximately 0.41, 1.10, 3, and then 8.15. And so now I'm just going to graph those. So here I have -2, 0.41, -1, 1.1, 0, 3, and then 1, 8.15. And again, the x-axis is the asymptote, so I'm going to follow the x-axis and then go up those points. Okay, let's look at one more. So here I have f of x is equal to e to the -0.5x. So first I want to see if this is exponential growth or exponential decay. So my a is the number that is in front of e. So here there's really a 1 right here. So a is equal to 1, which is positive. My r is the number in front of x. And I see that's negative 0.5, which is less than 0. So since my r is negative, this is going to be a decay. Okay, so now let's go ahead and find these values. So here I'm going to instead use -4, -2, 0, and 2. And the reason why I do that is just so I can get an easier number that's in this exponent here, since I'm multiplying it by -1/2. And so when I do that, I get e to the negative 0.5 times -4, I get 2. And then negative 0.5 times -2, I get 1. E to the 0, and then e to the -1. So I can come back over here to Desmos, and I can change this out to be negative 0.5. And so I get these numbers. So that means that this is going to be 7.39, 2.72, 1, and 0.37. So graphing these, I have at -4, I go up to 7.39. -2, I'm at 2.72. 0, I'm at 1. And then 2, I'm at 0.37. So I start up high, and then I follow along the x-axis.